Hello and welcome back to part 2 of our chat with Abbie Hutty and of course Lewis Dartnell joining us again. We have been playing Kerbal Space Program in part 1, and if you haven't seen that, go and watch it because...
With only modest success.
Yes.
Don't watch it for a tutorial. We sucked. We sucked at that game.
We did. And this is sometimes what happens when you apply real life science, or at least real life thinking, to video games. But interesting nonetheless. Check out part 1. Part 2, as always, we have a bunch of your questions from Facebook and Twitter and YouTube, and we're going to field those, and hopefully we can field some ones that...
And hopefully Abbie will be able to catch some of them.
Yes, I'm hoping. But I'm actually going to jump in first, if that's all right, and specifically about ExoMars. And I wanted to know, how exactly is this different from other rover missions we've sent before?
Okay, ExoMars, basically the fundamental science objective is different. Mm-hmm. So the previous missions that have gone to Mars have gone to look at what the environment is like on Mars. A lot of them have had the stated objective that they're looking for the conditions to support life on Mars. So that's basically, as humans, could we go there? Could we survive? Mm-hmm. We're looking for life on Mars, past or present. So it's a very different question. Is there life on Mars? Is there alien life on Mars? If there is life on Mars, has it spawned completely separately on Mars, or has it come from the Earth? All of those kind of are we alone in the universe type questions. That's what we're looking at.
Nice. So that does mean sending a whole new rover that does a bunch of different kinds of tests anyway.
Yeah, absolutely. So the thing that we're doing that nobody has ever done before is we've got a dirty grate drill on the front of our rover, basically.
Cool.
So it
clean grate
really
drill, so it can contaminate Mars.
Yeah. Dirty grate drill.
Yeah.
So we can actually get 2 meters below the surface, which down there you're below the perchlorates, the oxidants in the soil.
The nasty stuff.
The nasty stuff.
On Mars.
And you're also down below where the radiation would penetrate to. So actually that's a kind of cushy area that if there was life, it might still be lurking.
And we're still looking for minute scraps of life. We're not looking for like underground moles or anything like that.
We would love to find underground moles or wombles or clangers or whatever, but no, we're looking at really kind of single cells at the best, maybe
mini
just
Martian
kind of
bacteria.
tiny little organisms, that kind of thing.
And you are structurally engineering the ExoMars rover.
I am, so spacecraft structures engineer for the rover. Basically that means that I'm in charge of the body, the actual chassis of the rover.
Mm-hmm. Cool. So in terms of building a rover like that, is this rover bigger than all the ones we've sent before?
It's not actually. It's smaller than Curiosity, which was the most recent NASA rover. It's more down to the kind of size that Spirit and Opportunity were, a bit bigger than them, but that kind of ballpark.
And if you had to give that a real life equivalent,
we're looking at maybe the body of a golf buggy, that kind of thing.
Okay.
So it's maybe about waist high and about 1 meter across.
Golf buggy with a drill.
Yeah.
Is what we are sending to Mars
Absolutely.
to look for underground bacteria.
Yes.
Excellent.
Nice.
The next question we've got, in fact, links in very nicely to this. Will people ever go to Mars or just robots?
Well, there's definitely pros and cons to both. I mean, robots are great. We can do an awful lot with robots. We can make them very intelligent now. We're making ours pretty autonomous. It can drive itself around on the surface. But we're always going to want to make those fundamental decisions about where are we drilling and why. What is interesting? What makes this interesting? Is it worth the effort? So, yes, sending humans there would be great. You've got that inspirational kind of human connection that we all have. We are much more interested in astronauts in the International Space Station, what they're doing, than we are satellites that are going around the world. But equally, if a satellite blows up, nobody dies. If the International Space Station blows up, that's a problem.
People don't mind if your space probe, your robot, misses Mars by what? Of how many million miles do we miss it in our play of Kerbal?
What's 1/4 of
an entire
Mars's
orbit?
entire
We missed by
orbit?
4 months. We missed by such a long distance. We missed by 4 months.
We can't
of his
measure
orbit.
it by distance. It has to be time. I mean, not all of us are built to do this kind of thinking and engineering. So I'm glad that at least 2 people in my life have this skill.
And I guess robots are quite a bit cheaper than sending humans to Mars as well.
Well, robots aren't cheap.
But relatively, comparatively.
Well, they're complex in different ways.
Lewis, you were asking us to put a price on human life. An age-old question.
For you, my friend, about a tenner.
And it turns out that it's a little more than that, I hope.
Well, yeah, so if a robot blows up, you have a financial impact, but you don't lose a life. So you've got to weigh that up. Robots you can send there and you don't have to bring them back. They don't have to breathe oxygen. They don't have to eat food. So you've got a lot more simplicity in that way. You don't have to survive the radiation in quite the same way that a human does. But humans will be much better at making observations and just generally knowing instinctively what's interesting, what we want to look at, what we want to know, whereas a robot has got to be pre-programmed for all of that stuff. So you
Swings
can do,
around about space,
you
isn't
can
it?
do a lot of science with a robot. You can learn a lot about an environment with a robot, but you always lose that human element with a robot. So there's always that drive, that human need to explore that isn't quite fulfilled by a rover, and that's why it's always the next step can we send humans there?
Sure, and does that mean as well that the challenges of actually making a rover that can travel across the Martian surface driven by a robot for the most part, does that add its own level of challenges, or is it more or less just saying, well, it's the same as driving on a beach?
Fundamentally, from a mechanics point of view, you are just driving on a beach. It's colder than most beaches.
It's red.
It's red.
So a British beach then.
British beach,
Okay,
definitely
yeah,
British,
that's
maybe
fine.
even Scottish.
Wow.
But you've got less gravity. I mean, that's not a problem. If anything, that makes it easier. You've got fine dust, really fine dust on Mars, and that gets into all of your mechanisms and things. You can sink in the sand just as the same we can here on beaches, and so you have to be able to work out how you're going to get out of that or prevent it happening in the first place. But fundamentally, it's just driving. We can do driving. The problems, the challenges with Mars that are a bit different are the variation in temperature. Day to night, I mean, it gets really cold on Mars, like down to minus 130 degrees centigrade.
Frosty, yes.
That's pretty nippy.
Yeah.
And by day, you hover around 0. If you're lucky, it could be down at kind of minus 50. And you're driving around in that. And just the kind of coefficients of thermal expansion, the actual amount that materials expand and contract over those temperatures, printed circuit boards and stuff like that just tear themselves apart. So we've got a lot of materials challenges with the rover, just making sure that just the temperatures don't destroy it. You've got the radiation, which is damaging for all of your processors, your software and stuff like that. You get a lot of bit flips and kind of false readings.
I like bit flip. That sounds like something acrobatic.
Yeah.
So you have to have lots of backup systems to make sure that you're not getting errors and glitches in your code coming from radiation bombardment, stuff like that. So you've got a lot of different challenges.
That sounds like a lot of things to go wrong, to be honest. I mean, even down to the materials not being completely brittle at those kind of temperatures. Because I'll give you an example. We take our cameras, to film different things, and if the batteries get below, I don't know, freezing, or much below that, they suddenly become useless.
Yeah, absolutely.
How do you even power something when batteries won't even hold charge in the cold?
Well, that's one of the biggest problems, is just the batteries, the fact that we've got to keep them warm. So you've got to expend energy to keep your batteries warm.
You're using the energy, the electricity in your batteries to run heaters to keep the batteries warm enough to
and that's what
run.
will kill us eventually, is because batteries, you have your charge, decharge cycles, and you only survive a certain amount of time. And you've got to expend energy all of the time heating yourself up. So when you don't have enough energy in your battery to run the heaters, that's when you die.
Well, I should probably ask some of the other questions that I tend to kind of run away with these because they're so interesting. But another question is, how much easier would it be to launch from Mars? Assuming, I guess, we've already made it there somehow.
Okay, well, so there's two sides to this, obviously. One side is it's easier to launch from Mars because there's less gravity. Mars is smaller than the Earth. You have 0.38 of the gravity that you have on Earth on Mars. So it is fundamentally easier to raise yourself off the ground on Mars. You could jump higher on Mars, that kind of thing. But then you've got the infrastructure. So we didn't have it too bad when we were playing the game earlier, Kerbal. But if you don't have a proper launch pad, it's not completely flat. You get all the turbulence when you actually fire your thrusters, that kind of thing. So to be able to launch off Mars safely with some kind of degree of control, you probably basically need to build yourself a whole launch facility on Mars. So the amount of stuff that you've got to send over there, the amount of kind of robots that you've got to have there to construct this thing, and then you've got to have all of the fuel that you're going to use, burn up to launch yourself, all that kind of stuff. You'd have to send a lot of missions before you could then think about lifting off the surface.
To send anything back,
yeah.
Because there is one plan, isn't there, for Mars sample return after things like ExoMars, where we, miniaturise our entire laboratory into something the size of a shoebox and try to stick it on the back of Rover. that we would just send something to pick
Yeah,
interesting samples from Mars and bring them
we
back for
can
us?
do a lot with the miniaturized components in the rover. We can have spectrometers that small. We can do a lot of spectroscopy and all that kind of stuff. But it's never going to be as good as it would be in our labs back home when we've got massive devices that are really accurate. So we would like to bring a sample back, but then you've got to get it off the surface and back to some kind of vehicle waiting in Mars orbit, probably. And here we're only talking about maybe a little canister of soil or something like that. And you might be able to launch that with some degree of success without all of that kind of facility. You're not talking about a full manned space vehicle, and you're probably not talking about coming all the way back to Earth with that. You just go up to orbit and mate with something
You've
up
left
there.
a rocket motor in Mars orbit that you have to rendezvous with and send yourself back home.
But it's still not simple.
I'll see if I can build that for us in Kerbal.
Yeah.
Look forward to that.
Yeah, it should take me about 15 minutes, I reckon.
Since launching rockets from the surface of the Earth is very difficult, why don't we just use big helium balloons to lift things up and then launch the rockets from there? So we're not kind of wasting all those tons of fuel. Would that work?
Fundamentally, yes.
Yeah.
Helium's lighter than air, so it displaces air and lifts you up. If you have a big enough balloon, you can lift things with it to the weight of the displaced air. When you get further up in the atmosphere, there's not as much air. You're getting very close to the place where you're actually at a vacuum. And at that point, basically your balloon's going to pop because you've got no pressure outside the balloon. You've got some pressure of helium inside the balloon, so it's just going to pop. So you can only get to a certain height in the atmosphere with helium. So yes, you can get a long way up, but you're going to have a shed load of helium to be able to lift anything really interesting. So if you were talking about lifting a rocket, the size of this helium balloon would just be absolutely
So we were talking like
ginormous.
Yeah.
to get anything interesting up into orbit, you'd have to be launching tens of tons, hundreds of tons, and a helium balloon big enough to lift, let's say 100 tons, is just absurdly, impractically big.
Absolutely. Plus, helium is a limited resource. We don't have that much of it. That would be quite a waste of helium.
To just throw it away into space.
Yeah.
Or let it burst in the balloon in the upper atmosphere.
Yeah.
Okay.
So no then, you're saying?
Yeah.
So
Space scientist has denied.
Yeah.
yeah.
Stick to your
Physically
rockets.
possible, however, hugely impractical.
All right.
Yeah. Okay, there we go. So the next one is, can a spacecraft really be maneuverable as fighters? And if so, how hard would it be to make that work?
Okay, so I haven't actually played Call of Duty myself, but I'm assuming these kind of swooping,
Yeah,
swirling,
kind of banky,
Yeah.
dogfighty.
Yeah. Not so much, really. Basically, all of those kind of grand sweeping manoeuvres and trajectories that you get are what you have in air. It's all about control surfaces and lift and wings and drag and those kind of things. And we don't have that in space. You literally don't have any air that you're passing through. So it's just about what force you've got, and you keep going in that direction. We have thrusters, so we can sort of do quite sharp little manoeuvres, affect our tilt and our pitch and our yaw and that kind of thing. But it's just a little puff that you fire out the back, and that adjusts your trajectory, so you just dart around.
You're not making dogfights between TIE fighters and X-Wings sound all that much fun at all.
It's not quite as
You would
glamorous.
have two things
and
flying in a straight
beautiful
line,
and-
shooting guns at each other.
Yeah, basically.
All right.
Yeah.
We got another one, which is, what do you think is the best way to fuel rockets going to Mars, and why? And following on from that, there's a question about using ion drives.
Okay. Mars, it really depends what you're trying to do. If you're sending a robot there, maybe you're not that interested in how long it takes to get there. So an ion drive is very efficient. You're basically making energy through solar panels or something like that, electronic energy, and you're firing ions out the back. But ions are really, really tiny. So, for F equals ma, you're only going to accelerate as fast as the mass of the thing that you're throwing out the back.
And the mass is pretty
the mass is
minute.
really tiny. So whilst you don't have much resistance, it's going to take you a very long time to get up to any decent speed. You can keep firing them constantly and keep accelerating, but it's going to take you months and months and months to get up to a decent speed. So if you don't care how long it takes to get you there, that's fine, it's very efficient, and you don't have to carry all of the weight of the fuel with you. But if you want to get there in a sensible time, especially if you've got humans on board
If you're
who
in a
are
hurry.
suffering the effects of radiation or something, then chemical propulsion is a much faster way to get there. It's
So in the future,
a lot
we
more
might
oomph.
send humans to Mars with chemical rockets, which are big and powerful, and they get you there quickly.
You could
but maybe
supplement
send
them
the
with
cargo
ion
with ion
drives,
drives.
maybe. But yeah, cargo or robots and that kind of thing, you can conceivably think that you could send with
Things
ion
that work in a
drives.
particular area.
What does that mean for slowing down once you get there, though? I mean, if it takes that long to accelerate, does it not also take that long to decelerate?
Yeah, it's also really inefficient to decelerate with an ion drive. So you'd probably still need some kind of chemical propulsion there to slow you down. Otherwise, you'd have to stop accelerating halfway and start decelerating again at that same point to be able to slow yourself down in time.
Double whammy of inefficiency.
Yeah, always with the chemical rockets.
Yeah.
Not going to get any organic health rockets in the near future.
Well, there you go.
Our next question is all about interplanetary trajectories and why might it be more difficult to go to Mars or other planets rather than just up to the moon? Why is that a very different prospect?
Well, for a start, it's a lot more accurate an angle you've got to hit. So the moon from the Earth is quite a small angle.
Easy
see it in the
target.
night sky.
Yeah.
It's a small angle, but it's still measurable. You can still see it and point at it. So that degree of accuracy is less stringent. But also the moon is always a certain distance away from the Earth. You can launch as efficiently to the moon at basically any time. And it goes around pretty much every day. So you can see it at some point every day. You've just got to launch at the right time of day. To get to Mars, because Mars is not orbiting the Earth, it's orbiting the Sun, you've got to wait until your orbits align. It's also a lot further away and it's a lot smaller. So you've got all of those hits. You've got to be a lot more accurate in where you're pointing. You can only launch...
Look at you now, Seb.
I know. And
at a certain
I can
time.
only apologise.
Not when Mars is on the other side of the sun.
Wrong side of the sun, was it?
Anyone wondering why I'm being accosted
Chastised.
here should go and watch part 1, where I didn't get us to Mars.
And it's a lot further away, so you've got to have a lot more fuel on board.
And I suppose you don't have a lovely visual mapping reference like I did, which just says it'll be this much to get us in line with that orbit, and then definitely you've got to do it all based on a piece of paper and maths.
Not maybe computers nowadays.
Oh, yeah.
I think,
mean,
at least a calculator.
Yeah.
A Casio.
Okay,
You've got a Casio.
you're allowed one calculator. So yeah, that makes a lot of sense. All right, hopefully a quick and easy one here. Where is north or south on Mars when it doesn't have a magnetic field?
So an interesting one. It depends, what your definition of north and south is. Mars has an axis. It has an axial tilt that it rotates on, and that's what gives it the seasons. So you could define that axis to be a north-south axis like we have here for our axial tilt, which is actually not quite the same as the magnetic pole of the Earth. But Mars doesn't have magnetism. It doesn't have a magnetic field in the same way that we do here. So there fundamentally is no north and south, magnetically speaking, of Mars.
But it still turns and it's still got a rotational axis.
Yeah, and
rotational
so
poles.
for simplicity, we have nominally named one pole the north and one pole the south, just because that's a concept that we all get and understand.
And it's from that we then have, kind of longitude and latitude and coordinates on Mars is from that axis, from those poles.
So when you've got other planets in the solar system that maybe don't rotate so much on a north-south, but maybe on a sort of east to west divide, do you still think of that as north and south?
Well, like Venus, I guess, which is essentially turned upside down and is rotating in the opposite direction.
Yeah, it's a slightly ambiguous concept because it's not magnetic, but it's still an axis of rotation of the planet, so you can still think of it in that way if it's useful to you.
Sure, cool. Do you want to field the last one?
Yeah, finally.
A very serious question. We saved the serious one for last.
I mean, this is close to my heart as well.
Yeah.
Can you tell us, Abby, if you can, why is it that a fun-size Mars bar is called fun size when they are plainly much, much worse?
Not fun size.
There's
no
not.
fun at all.
It's not
size.
party size.
Yeah,
They're misselling it to you, aren't
they? No, sad size.
Is this the kind of attitude that has to be adopted, though, when you're thinking of attaching things onto a spaceship? When you're thinking, size really is very important, keeping the weight down. So when you're talking about, I'm afraid that equipment's too big, we need to fun size it.
Fun size
just to keep the morale up.
Yeah, I might bring that in at work one day.
Is there a way that we could sort of implement this way of thinking into the
it
actual
needs to be
science
more
of
compact,
Mars, as well as the
it needs to be more fun size.
delicious snacks?
Yeah.
Well, there we go. I think we all learned something, especially at the end. So yes, thank you very much, Abbie, for fielding A, the questions, and B, suffering my attempts at getting us to Mars. And I'm so sorry that we didn't. I'd love to have another crack. As I said, it was never meant to be a tutorial. It was never meant to be a tutorial on how to get to Mars.
We could maybe have watched one or two tutorials before we had a start.
I'm not going to lie. I watched as many as I could. I've watched at least 4 different tutorials. Not just about getting there, but getting there, landing, leaving and coming back.
It's a tricky game. It's a great game. It's very in-depth. Great physics engine, hasn't it?
It really is. I mean, I've not had a lot of time with Kerbal, but the time that we did spend, it was a lot of fun. So definitely check it out. But yes, that does bring our Q&A session to a close. Thank you, Abbie. Thank you, Lewis, as well.
Thanks for having me.
Next up, which will be our 6th and final Space Explorers video. I'm going to be massively egotistical here. We've saved the best to last, haven't we, Seb?
Do you know? In terms of guests, it's just you.
Well, we got cancelled, so I had to step in at the last minute.
Yeah,
and it's me.
It's going to be Lewis. So it'll be Cam, myself, and Lewis.
So some really terrible questions, please, for next week.
Yes.
Yeah. If you've got any questions about farting in space, firing guns in space, you send them in. For next week.
And we're going to be playing Waking Mars. So we're talking about the biology side of this, which is your field of expertise.
This is what I do. I do the astrobiology. So anything about Martians and bacteria and how we search for life,
all that good stuff,
on other planets.
Yes,
send them in.
If you've got any more Mars bar based questions as well, obviously we'll take them. But until next time, thanks very much, guys. We will see you in the next video for more Space Explorers.
Bye bye.